Hello, welcome to the Cluster API Provider AWS special meeting on v1alpha4 networking API. Today is Thursday, 5th of November at 1700 GMT. So I haven't really got, this is pretty much an open agenda. I hope people have sort of taken a moment to read through the sort of user stories and requirements, the goals, and I'm just opening it up. I would like to hear what people think they're missing or ideas about how we package a UX around this. Anything really. I'll take notes. Or we can go through the just go through the docs bits. So I haven't done much with the design yet. I'm still sort of been talking to people and seeing what we need to do. So in terms of the sort of high level goals, we basically want to support existing infrastructure. So that sort of unmanaged, what is currently unmanaged VPC behavior, want to preserve that. We want to rewrite the reconcilers right now. So the history of the controller is this controller was originally written before CRDs became available, before controller runtime even existed. So a lot of the original AWS cluster logic predates using controller runtime, and it basically has a linear flow in terms of doing Operation AWS, waiting for them to finish, which is not really Kubernetes way we should be using. We should be attempting operation, requeuing an object, and then letting the Kubernetes controller runtime sort of sort out retries, etc. So rewriting that. Removing the spaghetti nature of the current AWS cluster controllers, that's related to the above. I'm finding it increasingly difficult to review code. I'm sure others are as well. And we're seeing frequent bugs popping in the AWS cluster reconciliation only. Like the AWS machine is fairly reliable as a controller. We've had occasional issues that pop up when AWS itself changes behavior, and we've had to account for that. I'm not even sharing, am I? But the AWS cluster controller frequently has bugs. We've never had a strong contract on the existing infrastructure, which has led to some of those bugs, even in the 0.6.1. Next part is like we want to sort of rewrite the API and rewrite it, I guess, once, so that we can move to beta and GA without having any other major API changes, and provide a UX for provisioning clusters voids, basic people trying to recreate CloudFormation or Terraform templates if possible. Some of that is slightly unavoidable given the probable design, but that's basically how it's looking. In terms of user stories, I took some directly from issues. So people were using Direct Connect, just create the issue straight out of that. Story 2 is very much based on is also related to Story 4B. So this is based on the UK official recommend standardized architecture, which is sort of jointly developed between AWS and the National Cybersecurity Center. And it's really the sort of current gold standard for producing multi-account secure network design, essentially, using the latest features, using AWS Transit Gateway to connect VPCs together. So there's a variant of that, which is the NIST standardized architecture, which is the same, but without using transit gateways, which was a So transit gateways were introduced in 2019 or late 2018 around VMware, I think. So I think the NIST standard has not caught up with that yet, but the UK one is a bit ahead. So I think that's like a good reference architecture to be able to support that. And then finally, adoption of existing resources. So I'm this request in Slack, which I transformed into a story. I'm open as to how important people think that is, but I put it down as a story nevertheless. It is a request. It doesn't mean we have to do all of these, but I do just want to sort of enumerate the space in which people want to have clusters and the way they think they should operate. And then finally, I've got this story 5. This come out from discussions earlier this week around, so there's going to be a new construct in v1alpha4 cluster API, which is the machine load balancer. So load balancers are being broken out of infrastructure providers are going to exist on their own. This is primarily to support bare metal and on-premise environments. And so it's not directly relevant to us, other than that we need to support it. But there is one story here that where if you're using VMware on AWS, you may want to create a vSphere cluster on VMC on AWS and use an AWS network load balancer for the control plane load balancer. So that is that's a statement that we support the v1alpha4 load balancer provider constructs. So I then have not mapped these all out into requirements, functional requirements, non-functional requirements, try and link them back to stories. So we've got some traceability, and then, yeah, and then the design will follow from that. So open to questions, comments, concerns, ideas.
So with story number 3, the adoption of existing resources, how far are we expecting that to reach? Like, is it just the VPC like networking sort of layer, or is there potential there for taking existing clusters, for example, and bringing them into a cluster API managed environment?
It would have to be, so yeah, I think probably we'll need to clarify this. So it would have to be in this circumstances, just sort of the EC2 resources short of the cluster itself, because we can't solve adoption of an existing cluster can't be done from here. It has to be done through other cluster API controllers. And like if you've not provisioned through kubeadm, for example, it makes it quite difficult to, like, how do we figure out that state? So I think, yeah, it's a good shout. I need to clarify it.
Yeah, so would this then cover taking the management of the kind of bring your own infrastructure sections, then, the way you're providing your own subnets already created, then after the fact, Cluster API can then start managing those?
Yeah, that's right.
Yeah, okay, that sounds good.
Yeah, I have a question. So I saw there's a bunch of underlying reconciled resource like VPC security group. So I'm not sure if this is a typical industrial use case, but in our company, what we did is we have separate teams, security team, network team, to configure all those resources through Terraform. So they are not. So I was thinking if there a way for our v1alpha4 API, we can opt out some resource reconcile process. So that is one thing I would like to know. Can you hear me?
Yes. Sorry, I was just I'm pausing. You can do that today, kind of, with v1alpha3. But we've not properly documented the contract. So today, you can use, and we call it unmanaged mode, and you can provide the VPC subnet security groups as long as you respect the expectations of what Kappa needs. So, but it's not an explicit, like, don't touch my stuff. It may still attempt to reconcile those results. So there is sort of, there's an unmanaged flag, but not everything is completely unmanaged. So can I just check in your environment? Can you roughly enumerate what those resources would be?
It's like VPC security group and subnet. That is, yeah, those things is configured by Terraform by other team in separate way. So our team is only responsible for EKS, and yeah, and we still, and yeah, that is. I mean, yeah, because from API itself, I don't saw the flag to declarative says this field is not managing, this field is managing. So
yeah, makes sense.
Yeah.
Anyone else?
So I have a question regarding, again, adoption of existing resources. For example, for an unmanaged VPC, if we want to adopt it as cluster API resource, and if there are other resources that is on, for example, say that VPC, we are not actually will be able to manage the life cycle of that unmanaged VPC. How? So we should determine in which situations we will be able to adopt and make it clear, I think.
Yeah, there's actually an existing problem right now as well. So, say, I think many organizers, I mean, I don't know who's actually doing this, but I know some people have at least experimented, and certainly from my time as a consultant, I know people who were like trying to use the early versions of Service Broker, and I guess now, and then that became AWS Service Operator and is now AWS Controllable Kubernetes. If you might have a case where even for a fully managed cluster, somebody requests someone requests a RDS database from ACK. Now that RDS instance is now launched in that VPC that we were fully managing. Now, what is the expected behavior when someone deletes a cluster? Do they want all their data deleted? Is it even possible to do, like, well, is one, they won't be able to delete the VPC anyway, because the RDS will show up as an existing network interface that's stuck on that VPC and can't be deleted. But then what is, even if we could delete the database, what is the expected behavior? I think that's an open question, way more so for the ACK team. But yeah, I don't think that's clear at all. Marcus?
So just on that, I think my expectations of that scenario would be any infrastructure that we brought to Cluster API would remain afterwards if we remove the cluster from it. So if we brought a VPC and a subnet and whatever, I would expect those to remain after removing of the cluster. Mainly because we would likely have other things set up along with those. For example, like Direct Connect set up with VPC to back our on-premises stuff. We would have, like you said, databases and things like that, potentially pre-Kubernetes environments, so stuff just on EC2 instance and things like that. That's the sort of scenario that we are likely going to be seeing in the coming months with our teams. So yeah.
Just to clarify, so you, in that situation, you're already going to start off with VPC that's already created and bring it along.
Yes,
right?
Yes. But it would still be nice if Cluster API could then manage that to some extent, but not the deletion afterwards, if it comes to that.
So I almost suspect we need something a bit like the way PVCs work then. Like, what is it called? The delete
Retain.
yeah.
Yeah.
Okay, cool. Thanks for that. Jonathan, so you've unmuted.
Yeah, I'm interested in story 4, these standardized architectures. What's the switch for these? Is there some kind of, are we considering some kind of flag, or are we picking one as like a base and then adding feature flags on top of it for the differences?
Well, none of those. So the UX is interesting. So I think what we essentially going to end up with is CRDs for each of the resources, and then you somehow construct these together to form. So the reference architecture will be just something that looks kind of like a CloudFormation template, but is a bunch of CRDs. Now, the question is, so it's all very well that you create an AWS EC2 VPC security group, VPC endpoint, VPC peering. That's fine. Well, it's not fine, but you could create those CRDs. We need some mechanism to be able to like package up a way to provision clusters on demand. Like, I don't think it'll be enough to just have a template, like a flavor, like we do with Cluster Cuttle now, and that template just has a load of like M subs variables and all of these CRDs, and you go and like just stamp out 20 resources every time you create a cluster. I think we need I mean, I could be wrong, but I think we do need a mechanism to sort of almost declare a template of some sort. And then you can just have 3 or 4, maybe the core cluster API CRDs and one cluster template, which then underneath creates these individual CRDs, but not have the user require to explicitly declare all of these resources every time they want to create a cluster. Is that an unfair assumption, or I don't know? I mean, it's more work to do it that way. So against it, that's less work.
It's a lot of CRDs, but I think I know what you're getting at.
Is the expectation that users will interact with these CRDs in some way? Because this is starting to get very close to what's underneath. So it's very close to the actual infrastructure. Whereas one of the main benefits of cluster APIs, it kind of abstracts that away, and you're then just dealing with kind of Kubernetes native sort of thing. So if it's getting to a point where it's mapping almost exactly to the resources it's creating, one, is that going to be is that going to lose some of the benefit of cluster API? Two, is it going to be able to keep up with new features coming to AWS and all that kind of things?
Yeah, I agree. So, I mean, that's really the UX question. That's why I think we do need that mechanism to be. So the benefit of having these resources which sit quite close to what the infrastructure is that we can easily make the reconciliation controller, or even in the future defer to AWS controller to Kubernetes. So we have a thin wrapper. It might end up just being a thin wrapper around that service. It means that we don't have a load of spaghetti conditionals in an AWS cluster resource. But yes, if we're talking about the goals of cluster API, we want to make provisioning clusters easy. This makes it harder. So I think it is a requirement. I think that to me indicates a requirement that we even if this is an underlying, most of this is going to be internal to basically the operation of the controller. This is not the way we want users to interact with it necessarily.
Would we still have spaghetti code when all these underlying reconciled resources have their own dependencies on each other that the AWS API doesn't manage, but we would have to?
Yeah, we need to figure that. Yeah, that's one of the things that needs to be, how do you cross-reference these is something that we do need to address as well. But one of the benefits of this is that we're using, but even if we are having to cross-reference resources, we can use a Kubernetes mechanism of just waiting for a ready status and then getting in. But like, they're still going to be fully independent controllers. So the spaghetti nature is emergent rather than something hard-coded. Anything else?
One last comment about that then. If we're using Kubernetes controllers with weights and error catching, I think I read something in the document about how we're already dealing with AWS API limits. So that seems like we would run into that a lot more often.
I agree. So yeah, so I think we need to make some. Hold on, I'm just going to shut down Slack. I was going to say. We need to make some explicit statements around how we're going to deal with that. I agree. So there is some cross-company work starting up with AWS to try and address some of this because they're going to hit the same thing in ACK anyway. Yes, so I think we might need the ability to sort of opt out of continuous reconciliation almost. So say you provisioned in a single AWS account and you're operating at a certain scale, say, I don't know, 1,000 clusters, each of them has 20 nodes. You might at that point say, don't continuously like try and recorrect changes. I'm okay to have the trade-off that some of my infrastructure might drift over time for the benefit of not hitting the EC2 limit all of the time. Is that reasonable, or is that like a step too far? I don't know what people are running in production at the moment.
Would that be are you imagining that applies to everything, or would you be able to specify, okay, for this workload cluster, I want to make sure it's in sync, this one I don't, and that, you know, because if you've got that many clusters, there's likely that some are more important than other ones for you. There might be some that, you know, are just test ones, non-production ones, whatever, that you can be like, yeah, okay, they can be sacrificed for a little bit, whereas our production one that's hit by, you know, millions of customers needs to be how I think it is according to the code and things.
Yeah, I think it's I think it will be some sort of common field on a resource, like a reconciliation policy, and we'll have to decide what the options are. But from that will determine whether it will be create it and just ensure that it exists and do nothing else, or like describe all of the properties and ensure all of the properties are correct on every reconciliation, something like that. Yeah, but a common interface, and that then will allow you to opt out for like have your production high grade do check versus the developer clusters. You know, you're on your own. If you go into EC2 console and delete the control plane instance, that's on you.
A comment on that then. I foresee the need to separate out into multiple AWS clients rather than just use one for the controller. Possibly, and correct me if I'm wrong, because rate limiting is a configuration item for the AWS client? Or would that be handled through controller logic?
Technically speaking, the rate limiting is not part of the client at the moment. So you need to inject a request handler. So the model that we've settled, so I've got a work in progress PR which copied code from another AWS project, which is internal code, is internal to that project. So we couldn't directly consume it as a library. But what we would end up doing is creating regex-based buckets for individual API operations per AWS account, and then set up basically a token bucket that would exhaust to 0 as the tokens get replenished, or AWS signals that it's already hit the rate limit, and then that fills up over time, and then operations continue, and we'll just block then all of those operations. And what AWS is doing is they're going to take that code and put into a common project, and then we can import it in directly. So we should, and we're going to do that in the AWS cloud provider as well. So anywhere in Kubernetes should be set using the same rate limiting code. So that's the plan anyway to deal with that.
Is it likely that some of these resources would still be created in a more in a linear fashion like they are today? Because there's definitely some dependencies from one to the other, where it doesn't really make sense to try and create one before you know the other one's done. So rather than wasting time on, as if subnets, for example, rather than wasting time constantly checking for VPCs to be ready before doing the subnets, would it not make sense to have that as the next step after the VPC creation, for example, or that kind of thing? You know, like halfway between what we've got today and a controller for each thing.
So my thought on that is that if you're a controller for one resource and you need to check the status of another resource, you're doing that for Kubernetes. So you're almost using Kubernetes as a read-only cache for other resources that you're dependent on. So that subnet controller will just continue.
Does that mean that all properties that you need to consume from that resource will be stored as on the status or whatever of a Kubernetes resource?
Yeah,
right, okay.
Exactly. Oh yeah, I had the vague idea, so I don't know. So there's something called the VM operator project, which is currently in vSphere 7. And Cluster API provider vSphere is going to converge with it. One of the things we're going to do in that is actually have almost so they're going through similar things where you need to define a failure domain for vSphere clusters, and in the vSphere environment there's no region or availability zone. It's whatever is however the person who set up the infrastructure has designed it. So you need some way to represent that failure domain, and you can do that through certain vCenter constructs. So what the plan is in that model is that there's going to be a CRD for these quite low level vCenter resources, but it's going to be a two-way reconciliation. So it's actually just going to, so if someone makes a change in vCenter, then that automatically pops up as a Kubernetes resource. There's something interesting where we could use Cluster API AWS as like instead of doing a describe for every for each resource as it goes through its reconciliation loop, that there is actually some global, I don't know, I mean, this would be, I think it's quite long term, I don't think we'll do this now, but some mechanism where we describe all VPCs and they all pop up as CRDs, just for the purposes of being able to use it as a recache without hitting EC2. I don't think it's going to make it into this design, but it's something interesting that we're going to do for vSphere at least.
Do you expect that would also be the case when working with multiple AWS accounts?
Can you expand on that?
So, like for example, story 2, where you've got multi-account, multi-cluster layout. If you're looking to long-term have this kind of global, this local kind of view of all VPCs or whatever, is that not going to get quite expensive to consume from every account that you're potentially working with?
Yeah, yes and no. So I think we will run into an issue anyway where it depends how AWS does accounting for the operation, but you at least pay the sort of token depletion cost per describe operation. So if you look at the current model, if we're describing on a VPC, we do a describe VPC with the filter set to that. So and then for every VPC in that account, we are paying the cost of the describe VPC call. Whereas if we had a global view across accounts, we would do describe VPC with no filters. They would all pop up, and then the sort of the dependent resources can just read from Kubernetes. So it will potentially be cheaper. It will be more expensive in terms of etcd and the Kubernetes API server, but a lower load on the EC2 API, I think. Okay. Anything else? Okay, hold on. So I'm just gonna. Okay, so I'm just gonna pull up VS Code in a minute. Remember what branch anything is in. Okay, so right. So if we are going down the lines of having resources which are in some ways quite representative of the underlying low-level resources, then I think it also makes sense to do that even for the AWS machine. So, I mean, I literally have been, I mean, ACK is probably going to end up doing this as well, but, you know, if we're going to have the run it AWS machine spec, then we might as well be completist and do it once and have you able to specify all of the normal all of the fields that you currently do for ECD1 instance where it makes sense to. So I think then the next thing which I haven't figured out is what this location. So an AWS machine. So I think the failure domain stuff is going to change slightly, in the sense that if we do open up the AWS machine type, we also then have the ability to set placement groups, local zones, the AWS wavelength zones, sort of like 5G or whatever it is. And then that changes what it means to be a failure domain as well. So, and I think this then comes into the question of how we tie these resources together. So, yeah, I haven't got much further than that, but I think that's kind of how it's being looked like. So the location ref will be basically representing a CRD that describes a zone or a placement group or a local zone, etc. And then the ordering of things that are provisioned flow from waiting for those resources to be ready. So the AWS machine controller will wait for that location CRD to reach ready. And yeah, so that's sort of the flow of interactions between resources. I haven't got much further than that. I was literally just copying out the one instance API into something that made sense for v1alpha4. Any further comments? Jonathan?
Is it, since we're going to individual CDRs, is it at all feasible to use something that's existing? Like, I think you referenced the AWS resource controller for Kubernetes.
Yes. So in the short term, no, because the multi-tenancy model is a bit different, and also it's quite early days for that project. It's not doing much with EC2, so we will probably start contributing to that, at least from like we will evaluate that and sort of, and we may like contribute to that project to get into a position where we might consume it, but I don't think it's going to be in a ready state for v1alpha4 cluster API overall. which is why I think we will have our own individual resources, which might end up being a one-to-one, creates an ACK CRD anyway in the future. But this way we're not completely dependent on underlying implementation.
Okay. In the long term then, do you expect the Kappa controller to also include CRDs for resources that are not directly dependent for a Kubernetes cluster, like S3? Okay.
No, I think at that stage we have to say you're using ACK or crossplane at that stage. Like we anything that's in the direct service. So I think we're really talking about the EC2 API and the ELB v2. I think beyond that we have to say no, and you should be going to ACK. We're not in business of trying to compete with that project.
Right. I'm just curious.
I have a question. I want to go back to the discussion of introducing caches. How big of an undertaking is it, do you think, to like have it with all these big refactoring? Because we are gonna be doing quite big changes in the code base anyways. Would it make sense to also think about introducing caching while we are doing those changes so that our design will benefit from it? I'm not sure how big of a challenge having this caching design, but
yeah, I think there's a number of things. There is some existing issues that were opened up by I've forgotten now. Seth from who was at New Relic. So there's which one was it? Yeah, it's Seth. There we go. There's some short-term things we can do, like we can group requests together. And I think this is something I want to do for. They wanted to do v1alpha4 even, because actually, if you look at AWS Cluster Control, if you read through what it's doing, it's doing some stupid stuff anyway. Like it's constantly calling, re-looking up the same things, even though it's already looked it up like literally a second previously. It's just because we're not passing around the data enough. So we can make some immediate improvements by storing the information correctly on status or spec. But he did also put up a design for still keeping the sort of current model about doing individual calls, but sort of being able to group things together, like only wait for 5 AWS machines to come together to sort of come in for reconciliation and then do the lookup all at once and then give the individual results back. So that's one thing we should definitely look at. I think the global cache I think we should look at it. I think if we can do it, yeah, why not? I don't think maybe going down the VM operator route of continuous reconciliation between EC2, like having the EC2 resources pop up in the controller anyway might be a stretch too far, but at least even an in-memory cache would be good, I think.
yeah, this is mostly solving the inefficiencies in a single like controller. Since we are gonna introduce more controllers, like global caching would be great, but yeah.
Jonathan?
Will the methodology that we adopt here be applied to other cluster API projects like Azure? Because I see that VMware is influencing this methodology.
I think maybe I think that's a discussion to be had with Microsoft. So, but we have definitely converged on other areas anyway. So the multi-tenancy for Azure is going to be exactly the same as the AWS one. Well, with the caveat that the credentials they don't the way credentials work in Azure is not exactly the same. But that so the design of it is similar. From speaking plainly from a VMware perspective, I would need to go back and find out what from a product perspective, who's asking for it on Azure. I'm sure and if it's the same requirements, I'm pretty certain they are. So I would assume that we will probably go down that direction. Azure may want to defer completely to their own version of the AWS controllers Kubernetes. I forgot what I think it's called the Azure. I think it's called the Azure Service Operator. So I think that's just a discussion to be had with the maintainers of that project. But I don't see why we wouldn't converge. And Plus API vSphere is almost certainly going down a very similar route, and it's even more desperate for them almost because they just don't have a good way of representing failure domains at all, and you have to make them explicit. So for CAPRI, it's 100% necessary in a way that isn't for AWS. It would make sense for some convergence there.
If a lot of these projects are going to be doing the similar sort of thing, is it worth trying to push some of it up to the main cluster API project and have some sort of, I don't know how it would look, but some sort of mechanism there for storing state across providers? So then if you have, for example, if you have a management cluster that manages both Azure and AWS, you can leverage the same solution for keeping that state, or is that not feasible because of how each are implemented?
I've no idea. I think I think we'll do what we have done so far, which is where you start off with an experiment in one provider that might make its way into cluster API, and then eventually might make its way into controller runtime, because often these are things are not only related to cluster API. For instance, the AWS cloud provider has exactly the same sort of caching with its concerns, has exactly the same rate limiting concerns. I think if you look at the issue that Seth raised, it's almost the issue is emerged out of the interaction between the two different controllers. And one of them is running in workload cluster. So there's even a question around it's all very well having a rate limiter inside your controller, but then you've actually got multiple controllers which are doing the same thing for different reasons. And does that really solve the problem either? So I think let's start off and iterate in Kappa and then upstream stuff where appropriate. I guess we're coming to the end. So I'll leave it for final comments, and then I think maybe we call it and give you the last 5 to 10 minutes to get coffee, whatever next meeting you have. All right, and well, thanks a lot for your time. I will report. Oh, Xiao. Did you have something to say there, or?
No. Yeah. Just
Okay.
goodbye. Something.
Oh no. Oh yeah. All right. Thanks a lot for your time. I'll iterate on this design, bring it to the next meeting, and see how it goes. Thanks a lot. See you in next week.